Hello and welcome. In this video, we're going to take a look at how we can add FIDO2-related entities to ASP.NET Core 8's identity framework. As you can see here, I've created a new solution and added our identity web application. You can see here that we've got the basic view start file within our identity area. We've then got our create identity schema database migration. We have our application DB context class, and we've then got our applications pages. Last but not least, inside our program file, you can see that we're adding in our application DB context. We're then adding in identity, adding Razor pages, and then setting up our applications middleware like so. Now, the first thing that we are going to want to do is we're going to want to add a public key credential entity into our schema. So what we're going to do is we're going to right click on the data directory like so. We're going to click on add and then class, and we're going to call this class public key credential like so. Now, the first property that this class is going to have is an ID property, and this will be the globally unique identifier for the public key credential. So what we're going to do is we're going to say public required, and this is going to be a byte array. We're going to call it ID, and then we're going to say get and set like so. The next property that we are going to want is a public key property. And the public key property references the public key in the public key private key pair that is used to verify the signatures in the assertions provided by the authenticator. In other words, the authenticator will generate that public key private key pair when a credential is created. We will store the public key for that pair, and the authenticator will keep hold of the private key, and we will then use the public key that we store to verify future assertions when a user logs in. So what we're going to do is we're going to say public required. Once again, this is a byte array, and then it's going to be called public key, and then we're going to include the getter and setter like so. Now the next property that we are going to want is the signature counter. Now the signature counter is incremented for each successful assertion operation, and subsequent values are returned to us, the relying party, within the authenticator data. Now we store the signature counter of the most recent assertion operation, and that essentially tells us how many times the particular authenticator has been used to authenticate the user. So if the value provided to us when the user logs in is non-zero, and the new value is less than or equal to the value that we have stored in our database, then we can assume that either a cloned authenticator may exist or the authenticator may be malfunctioning, because the signature counter should only ever increment, it should never decrement. So the signature counter allows us to validate that the authenticator hasn't been sort of cloned maliciously and that it is functioning correctly. So what we're going to do is we're going to say public required, and then this is going to be of type uint, and then we're going to call it signature counter, like so, with the getter and setter. Next up, we're going to want a property to determine whether or not this particular credential is eligible for backup. Now, a backup eligible public key credential is often referred to as a multi-device credential, and that basically means that the credential can be moved between devices. In other words, it could be backed up from a particular device to a cloud account, for example. So a backup eligible credential is sometimes referred to as a multi-device credential because it can exist on multiple devices, whereas a credential that is not a backup eligible is sometimes referred to as a single device credential because it can only remain on the device that the credential was created on initially. So what we're going to do is we're going to say public bool, and then we're going to say is backup illegible, like so, and then get and set. And then next up, we're going to want to create a property to determine whether or not the credential is backed up. So the credential may be backed up in some way that means it's present on a device other than the device that generated the initial credential. Backup can typically occur via mechanisms including but not limited to cloud backup, for example, and also manual import-export of the credential. So if the credential is eligible for backup, this Boolean, either true or false, will enable us to determine whether the credential has actually been backed up to some other device or cloud account, for example. So what we're going to do is we're going to say public bool, and then we're going to say is backed up, and then we're going to include the getter and setter like so. Next up, we are going to want a property to store the attestation object. Now, the attestation object is given to us when the credential is created or registered, and storing this enables us to reference the credential's attestation statement at a later date for validation purposes, for example. So what we're going to do is we're going to say public required, and this is again another byte array, and then this is going to be called attestation object, and then we will include the getter and setter like so. And the next property that we are going to want is the attestation client data JSON. And once again, this is given to us when the credential is registered on the device as part of the setup process. And storing the client data JSON in combination with the attestation object enables us to re-verify the signature of the attestation at a later date. Once again, this is a byte array, so we're going to say public required byte array, and then we're going to call it attestation client data JSON, like so, and then we're going to add in the getter and setter. Next up, we're going to want a property to store the attestation format. Now, the attestation format is the manner in which the signature is represented, and various bindings that are incorporated into the attestation statement by the particular authenticator. In other words, this basically defines the syntax of the attestation statement. Different OS platforms, different devices, for example, can have different formats, such as TPMs and the Android OS, for example, to name a couple. And those in particular have previously defined attestation formats. And there are a few different well-known defined attestation formats in the FIDO2 and web authentication specification. So what we're going to do is we're going to say a public required string, and then this is the attestation format. And then again, we'll have our getter and setter like so. Next up, we're going to want a property to store the authenticator attestation GUID, also known as the AA GUID. And this is the globally unique identifier for the authenticator that created the public key credential. Some authenticators will have an AA GUID value. It's a 128-bit globally unique identifier, and it indicates the type, in other words, the make and model of the particular authenticator that generated the public key credential. The AA GUID value is identical across all substantially identical authenticators made by a particular manufacturer, and each AA GUID should be a unique amongst all other authenticators. It's basically a unique way of identifying the particular authenticator that was used to generate this public key credential. So what we're going to do is we're going to say public required GUID, and then we're going to say AA GUID, and then we're going to have our getter and setter like so. Last but not least, we're going to include the user ID foreign key, and the user ID foreign key will be used to link the particular public key credential back to a user within our application. So last but not least, we're going to have a public required string, and then we're going to say user ID, and then we're going to have our getter and setter. And that user ID then acts as the foreign key between the public key credentials table and the users table. So that is the basic public key credential entity that we are going to be persisting into our database. And next up, we're going to want to create a couple of relational entities, those being authenticator transports and device public keys. So what we are going to do now is we're going to right-click on that data folder. We're going to right-click and add a new class, and we're going to call that class authenticator transport. So we'll do that like so. And the authenticator transport is essentially a way to determine how a particular authenticator communicates with a client. So there are different methods for communicating back and forth between the authenticator and the client. Those can include Bluetooth Low Energy, for example. A value of BLE indicates that this particular credential can be communicated using Bluetooth Low Energy between the client and the authenticator device. NFC indicates that the authenticator communicates over near-field communication. And USB indicates that the authenticator communicates over USB. In other words, it sends the credential to the client over a USB connection. Those are just some of the common values: Bluetooth Low Energy, Near Field Communication, and USB, but there are a couple of other options, a couple of other transport types defined in the specification. So what we're going to do with this entity is we're going to, first of all, create a property for the public key credential ID. So we're going to say a public required byte array, and then we're going to say public key credential ID, and then we're going to have our getter and setter. This is a foreign key between the authenticator transports table and the public key credentials table. In other words, this references the public key credential that this authenticator transport belongs to or is related to. We're then going to have another property in here called value, and this is going to be of type authenticator transport, and that is going to be the authenticator transport from the FIDO2-Net library. So what we're going to want to do in order to pick up that type is we're going to want to hop into our NuGet packages, and we're going to want to do a search for FIDO2, and we're going to want to install the FIDO2.ASP.NET NuGet package. So what we'll do is we will install that like so, and then what that will now enable us to do is to reference that authenticator transport enum from the FIDO2.NET framework. And then we're going to give it a name of just value, and then we're going to include the getter and setter like so. So that's the authenticator transport, which, as I say, it's how the credentials can be communicated between the authenticator and the client. And what we're going to want to do now is create another entity, and this is going to be for device public keys. So what we're going to do is we're going to create a new class inside the data directory, and this is going to be called device public key. Now the device public key is something that we can use to enable continuity when we are validating or referencing public key credentials. So when a user generates a new public key credential for the first time, there is an extension to the web authentication specification that will determine whether or not a device public key will also get created, as well as the public key credential. Now, the device public key is created by the authenticator device, and it's the public key part of a public key private key pair. And that is, as I say, generated by the authenticator device, and then the device public key is returned to the client along with the public key credential itself. Now, when we use the public key credential in our application, we can verify the device public key to double check to see if the public key credential has been moved to a different device, for example. And that's because when we use the public key credential in an assertion, we can also opt in to receive the particular device public key of the authenticator that's making the assertion. So when you set up the public key credential initially, you will get the initial public key of the authenticator device, and we can then store that in our database. And when we then get an assertion, in other words, when the user logs in with that public key credential, we can also opt in to receive the device public key for that particular authenticator. And what we can do then is we can match the device public key within the device public keys in our database to double check to see if the public key credential is coming from the same physical authenticator device that was used during registration, or if it's a different device. And that's because when the public key credential is moved between devices, the actual credential remains the same. It has the same identifier, but the device public key will be different if it's a different device that is sending us that public key credential during login. So in other words, it enables us to double check to see if the authenticator is coming from the original device it was registered on, or if it's coming from a different device that the public key credential may have been backed up to at a later date. So what we're going to do in here, much like we did for our authenticator transport, is we're going to have a required byte array, and this is going to be called public key credential ID with our getter and setter. And as I say, much like the authenticator transport entity, this is the foreign key relationship between device public keys and public key credentials. And then what we're going to do is we're going to create another required byte array and simply call this value. And then we will say get and set like so. And this will be the actual device public key value itself. So now what we can do, now that we've created those two relational entities, we can add them into the public key credential class. So what we'll do, back inside our public key credential, at the bottom of the class, what we are going to do is we're going to create a public iCollection of type authenticator transport. And we're going to call this authenticator transports. And this is going to reference the list of or collection of authenticator transports that relate to this particular public key credential. And then what we're also going to do is create another collection, and this time it's going to be of device public keys. And that's going to be the list or collection of device public keys that are related to this credential. As I was mentioning when I was discussing the device public key entity, you can have one credential, but that one credential can be backed up and moved between different devices. So one public key credential could be associated or related to multiple different devices, and that's why we store the device public keys as a collection rather than a single device public key. So if/when the particular public key credential moves between devices, we can then update that list of device public keys with all of the known devices that that particular public key credential is associated with. Now what we're going to want to do is create a class or entity for the application user. So what we're going to do is we're going to right click on the data folder, we're going to create a new class, and we're going to call this class application user, like so. And the application user class is going to extend the identity user class from the ASP.NET Core identity framework. And what we're going to do in here is we're going to create a property to store a user's public key credentials. So this is going to be a collection of public key credentials, and that's going to be called public key credentials, like so. and that is then going to be newed up as a list of public key credential. So this is the relationship between our user entity and our public key credentials entities. In other words, one user can have multiple public key credentials. And also what we're going to do here is we're just going to do the same thing with the authenticator transports to create the new list of authenticator transports. And then we're going to do the same thing with our device public keys to remove the null reference warnings there from the getter and setter. So now we have our application user, which references our collection of public key credentials. And we then have our public key credential, which references its collection of authenticator transports and device public keys. We're now going to add these new entities into our application DB context class. So what we're going to do is we're going to open up the application DB context like so. And inside the body of this class, we're going to create a handful of DB sets to model those new additional tables. So what we're going to do is we're going to say public DB set authenticator transport. We're going to call this authenticator transports, like so. And then we can have our getter and setter. Next up, we're going to create a DB set for our device public keys, and that's going to be called a device public keys. And then last but not least, we're going to create a DB set for our public key credentials, and that's going to be called public key credentials. So there we have our three DB sets, one for authenticator transports, one for device public keys, and one for public key credentials. Last but not least, we're going to want to override the onModelCreating method to set up the tables and also the relationships between said tables. So what we're going to do is we're going to override the onModelCreating method like so. And within this method, we are going to configure those three database entities. So what we're going to do is we're going to say builder.entity of type authenticator transport. We're going to say toTable, and we're going to call this table FIDO2 authenticator transports, using that FIDO2 prefix just to help group the tables together in the database. But feel free to call these tables whatever you like, whatever meets your particular requirements or conventions. And then, last but not least, we're going to set up the composite primary key. So what we're going to do here is we're going to say a transport, like so. This is going to return a new object, and we're going to say transport.public key credential ID, and then transport.value, like so. That indicates that this table will have a composite primary key consisting of both the public key credential ID property and also the value property. Next up, we're going to modify the device public key entity. And much like we did previously, we're going to mark this entity as being converted to a table called FIDO2 device public keys. Again, though, feel free to name that table whatever you like based on your conventions or requirements. And then after that, we're going to give our device public key a composite primary key, much like we did with our authenticator transport. So to do that, what I'm going to do is again create a new object, and I'm going to, within that object, return the public key credential ID and also the value. Much like the authenticator transport, this will be our composite primary key, consisting of both the public key credential ID and the value. Finally, last but not least, we are going to set up the public key credentials table. So what we're going to do is we're going to say builder.entity of type public key credential. And this is then going to be written to a table called FIDO2 public key credentials. And then we're going to set up the relationship between our application user and our public key credential. So what we're going to do is we're going to say has one, and this is going to be of type application user, like so. And then we're going to say dot with many, And this is then where we're going to reference that user.public-key-credentials relational property that we created in the application user class earlier on. And then last but not least, we're going to say has foreign key. And then this is going to be a callback that we can select the credential.user ID like so. And that is how we can set up the one-to-many relationship between our application user class and our public key credential class. So that's the setup for our application DB context with the three DB sets, one for authenticator transports, one for device public keys, and one for public key credentials. And then we also set up the tables and composite keys for the authenticator transports and the device public keys. And then we also set up the table for public key credentials, and then we explicitly configure the one-to-many relationship between the application user class and the public key credential class. So now that we've made those changes to our application DB context, the last thing that we are going to want to do is to update the overriding of the identity DB context class within our application DB context. And that's because we've now overridden the default identity user with our custom application user class. So as you can see here, we currently extend the identity DB context class. What we're going to want to do is we're going to want to add in our application user type in order to extend the typed version of identity DB context, passing in our custom application user class as the type for the identity DB context. So now that we've done that, we can go ahead and add a migration for the FIDO2 related entities. So what I'm going to do is inside the terminal from within the web application project, I'm going to run the command .NET EF migrations add, and I'm going to name the migration add FIDO2 related entities. But feel free to name the migration whatever you like based on your conventions or requirements. So what this will do is it will build the application and it will then add that migration into our migrations folder within our application. As you can see here, we have our add FIDO2 related entities migration, and it's going to create a FIDO2 public key credentials table. It's going to create a FIDO2 authenticator transports table with our composite primary key. And it's then going to create a FIDO2 device public keys table, again with our composite primary key. And we can see here it's then going to add an index on the user ID column within the FIDO2 public key credentials table. So what I'm now going to do is I'm going to apply that migration to the database. As I mentioned earlier in the startup, if the environment is development, then I automatically migrate the database during the startup of the application. So what I'm going to do is I'm going to build and run the application like so. Give it a few moments there. And as we can see, it's applied those migrations to the database. So what I'm going to do to verify that is I'm going to open up the database view over here on the right-hand side. I'll refresh that public schema. And if I expand the tables directory, you can see here that we have the EF migrations history. We can see it's applied the create identity schema migration, and it's applied the add FIDO2 related entities migration. And we can see within the tables in our schema, we have the ASP.NET identity related tables, and we also have the FIDO2 related tables within our database schema. So this video has shown you how you can add those FIDO2 related entities into the ASP.NET Core 8 identity framework. I hope you found it useful. Thank you very much for watching, and I'll see you next time.